Hi, welcome to my presentation on gravity and orbits, where I will explore how celestial bodies move under the influence of gravity. I'm Wen Xiaozhu, and this is my student ID. This experiment is based on Kepler's laws of planetary motion, so before diving to the results, I will briefly define these laws. The Kepler's laws has three parts. The first law is the law of ellipses. Planets orbit the Sun elliptical path, with Sun at one focus. This explains why orbits are not perfect circles but slightly stretched. The second law is the law of equal areas. A line connecting a planet to the Sun sweeps out equal areas in equal times. This means that a planet moves faster when closer to the Sun and slower when further away. The third law is the law of harmonics. The square of planet's orbital period is proportional to the cube of its average distance from the Sun. In simple terms, planets are the further from the Sun, take much longer to complete an orbit. Question 9. Planet-Moon system. In this part, I switched to the planet and moon scenario and observed how Earth and Moon interact. Starting with question 9a, I noticed the Earth does move slightly as the Moon orbits around it. Unlike the star-planet system from earlier, the planet doesn't stay stationary. They move because both bodies and orbits around a shared center of mass. Moving to question 9b, I compared the center of mass in different systems. In star-planet systems, the center of mass lies deep inside the star due to its large mass. But in the planet-moon system, the center of mass shifts away from the planet's center, though still inside the planet. Finally, question 9c. The key difference is that the planet-moon system, the center of mass is closer to the moon, making the planet's motion more noticeable. In contrast, the star barely moves because the center of mass stays within it. In question 11, I measured the distance between the Sun and Earth using the grid lines and measuring tool. The distance came out to approximately 73.8 million kilometers, or about 0.5 AU. Each grid making in this mode represents about 0.25 AU. This helped me visualize the true scale of planetary distance. For question 14, I analyzed the data using Kepler's third law. I noticed that as the orbital distance increased, the orbital period also increased linearly, which is consistent with Kepler's law. This shows that the planets further from the Sun take much longer to complete its orbit. Let's move to question 15. According to Kepler's second law, planets closer to the Sun move faster in their orbits, while those further away move slower. The fastest orbital speed belongs to Mercury, the closest planet to the Sun. The slowest orbital speed is that of Neptune, the farthest planet. This is because the gravitational pull is stronger closer to the Sun, requiring planets to move faster to maintain their orbits. Through this experiment, I gained a deeper understanding of orbital mechanics and gravitational interactions. I observed Kepler's law in action, especially how orbital period increased with distance from the Sun. I also learned about mutual gravitational forces, seeing how both bodies in a system, whether star-planet or planet-moon, orbit around a common center of mass. This hand-on experience made these concepts much clearer and showed me how the patterns of solar system are governed by elegant, predictable laws. Let's conclude my explanation. Thanks for watching.